Yes. Okay, good afternoon everyone. So today we will start with another, in continuation with my previous lecture, that we are talking about urban areas, and urban areas, the inferences we had from urban areas, and when we are talking about urban heat islands, then the urban areas are not, first thing was not uniform all over the urban areas, right. They have different areas, have different contribution to urban heat island, simply because urban areas are made up of a lot of different type of surfaces. The canopy also changes from place to place. The typology of them also changes from one area to another area, and there are many. We talk about our Indian city, they are having heterogeneous, and when we talk about heterogeneous form, means form changes small distance itself, we see change very much. So you will find high rise buildings, and then to it you will find slum areas which will have a very contrasting typology. It became very important for us to as a scientist, as a researchers, to understand what kind of form is suitable for us. So for reducing our heat island effect, what should be the constituent of these areas, because we all know there are built surfaces, there are buildings, there are pavements, there are vegetations. So what should be that combination of components in that urban ecosystem that we need to analyze. So to start with, there was a system which is very recent, which is called as local climate zone classification, and this system was actually very recent. It is proposed by Stewart in 2012, and as per the basic classification scheme, what they did was they they did not look only on the buildings, but also what kind of vegetation is. So if you will look outside the buildings of Manette, so you will see there is G plus 2 floors, but some sparse vegetation here and there. And then if you go to say Newmarket area, you will find buildings and no trees at all. So that form is completely different. And if you go to another areas, if you have seen slum areas, definitely we all have seen what are the slums. So in slum areas you will find closely plagued low rise houses with very sparse or completely no vegetation. So that was a inquiry or an hypothesis. With this it was started. There are different forms. Can we classify these forms into different classifications? And apart from the buildings, we have to look into their forms, their heights, and also what kind of vegetation is there between those areas. Because till now all the research which was going on was on surfaces. What is vegetation, and all what is the percentage of land which is covered, which is paved, how much is the built area, what is the fraction of built area. So it was all till then talking about only the surface fractions. Of course that also has a contribution, but then we thought of, and after Stewart we started thinking about the 3-dimensional form of the building, which also contributes to the near surface air temperature, or at the canopy level, the form becomes an important characteristic. So this is the basic classification, in which there were 17 standard local climate zones which are classified. So you can see there are compact high rises. So in India it is very less, that we have only compact areas with high rises. So, maybe in Mumbai or now in Bangalore, Hyderabad, you will find some core area or CBD areas where there are compact high rises. Then compact mid rises very commonly found in India. Our FSI, our regulations results into such kind of compact mid rise form. So, in Bhopal you will see this is the form which is most prevalent, and more so it is compact low rise form everywhere. The reason, because there are many reasons behind it, because it is mainly the capital city, it has lot of government housing. So, there is ample land available. So, there are many bungalows, independent houses. So, it is open low rise characteristics which we see nearby. So, we will see small houses with G+1 with lot of vegetations near all around. Even if when we will go to managed campus and we will see the housing of faculty, we will see mostly these are open mid rise, low rise or mid rise housing. Then if you try to categorize how are the slums, you will see generally they are lightweight low rise. So, this was added later on because only compact low rise was not categorizing the slum areas, because they had very light roof, they had tin roofs. So, that was then it was categorized into lightweight low rise kind of housing. And so, this was there are many classification, even the industries were classified, and the main purpose of this classification was, as we can see, this is local climate zones. So, it indicates that these areas have a local climate formation or microclimate which is different from each other. So, if we are taking the measurements in these areas or air temperature in LCZ 1, it will be different from LCZ 7. So, that is what we are looking into, why it is so, what is that particular, and if even if it is different, it does not stop here. What should be the ideal height, density, form, compactness that we should adopt to have a like to mitigate the heat stress or heat island effect in at human scale. So, now categorizing a long press. Okay. When we are categorizing these LCZ, how did we start it? Because there are many parameters. So, we can just visually see that we were talking about the building height, mean height and aspect ratio. What is the height by divided by the width of or the distance between the two buildings, that is what is aspect ratio. But then we in this classification we have also added or they have also added sky view factor, terrain roughness, fractions, pervious surface fractions, this is fraction, and impervious surface fraction, friction, because it is also we have to see how much is the urban area, what is the patch of urban areas, surface admittance and albedo. So, these are the various parameters which were used to actually classify or create LCZ classification. So, I will quickly, we all mostly know what are these parameters and how are these classification done, but sky view factor, as sir has already explained, that it is the openness between the buildings. So, it is ranging from 0 to 1, aspect ratio is height to width ratio, and this is very important, because when we are talking in on practical now field, when we talk about, because it is not just on paper, we have to be also checking with the local building bylaws, what are the bylaws saying, because it is not, this is not a current science, they based on our studies which are done previously also, the bylaws, building bylaws are made, and building bylaws have been made to consider enough daylight, enough airflow in within an area, and for that a particular kind of particular aspect ratio was defined, that this much should be the setback, the building should be this much away from the roads, so that a particular aspect ratio can be reached, and that could be an aspect ratio which will give enough light and ventilation to a building or building typology. So, now we are questioning what it is not just 1/3 aspect ratio that will work. We have to look in beyond just classifying the height and width ratio. We have to see what kind of trees are there, what are the surrounding buildings, what is the impact of other forms on these areas. Then mean building height is just the height which is for an area. Roughness class is again what is the roughness, how much what are the height of the building and what kind of roughness they are creating on the surface is the roughness, to what extent. So, that is the roughness class. Then building surface fraction. So, when we look in plan, we see how much, what is the area which is being covered by building in a particular plot size. So, that also matters, because how much ground surface is open to sky and how much is covered by buildings. So, that is what actually decides what is the reflectivity, flow regimes, heat dispersion from the ground, etc. And it is the percentage that we look into, what is the surface fraction. Then impervious fraction again is the same thing, how much area is impervious in nature and how much it is open to sky, and also for water we see how much pervious a surface is, what is the moisture availability, and also the heating and cooling potential of an area. Pervious fraction, surface admittance is actually what kind of surface it is, whether it is soil, water, etc. Then albedo, as sir has already explained, the surface reflectance at a particular scale. Then yeah, so these are the different types of LCZs that we have classified, and this talks about compactness, compact, high, rise. So, now here we are clearly talking about how close are buildings and how high are buildings. So, we can see a compact high rise may be very different from say a lightweight low rise building. So, this is our hypothesis, and let us go and see how what kind of results we are getting. So, if you look into just simply what kind of compact high rise is, we can just go a different type of classification in actually. So, it is just an illustrative picture how a form is and how on ground it looks like. Okay. So, after this this is the tutorial which we will be doing for Bhopal tomorrow, because today we will go for observations. So, how to categorize this on for a particular city, how to create a scheme following the scheme, that we will do tomorrow. This is generally the types and sorry samples, training samples, that we will do tomorrow. Now, this is what we have done for collecting or training samples from Bhopal. So, this is Bhopal planning boundary. So, we restricted ourselves to the planning boundary of not planning, this is Bhopal Municipal Corporation area that we are taking, different wards, and then these colors show different types of LCZs that we have seen. So, that we have identified, verified on ground, and then classified into different local climate zones. So, you can see this is dominant one, that is compact mid-rise typology of LCZ throughout the Bhopal, and you can also think about like we have similar kind of typology, and this is open mid-rise, right? Yes, actually this study was focused only on the housing typologies. So, we restricted to housing, but water body will come under one kind of LCZs. So, these are from Bhopal itself, these pictures are from Bhopal, compact mid-rise. So, nowadays we see that row housing is very much into usable and also very much prominent in common in Bhopal and many other cities also, because it gives independent bungalow type typologies, and so this is compact mid-rise. So, most of the developers go for compact mid-rise nowadays in Bhopal. So, this is compact mid-rise LCZ 2. Compact low-rise is again, I would say, the sorry, old city areas, the core areas which were compact, and that is also was regulated through our bylaws. So, at that time the old city area did not have any regulations. So, it was compactly built, and they as much as space they got, they have built it. So, it became compact and it was low. Then open mid-rise. So, open mid-rise is mostly the government houses and the bungalows which are now sanctioned with a particular MOS to be left, how much is the FSI, G, and mostly it is G+1 and open mid-rise typologies that we see. And open rise are generally also, but they are in very less numbers. Then light housing is again slum housing, and large low rise are industrial areas, PHL and other areas are low rise. Sparsely built is again the farmhouses and the bungalows which are there all over Bhopal. Okay, so after this, this is the complete local climate zone map of Bhopal, where you can see that mostly this compact low rise, this is the old Bhopal area. Then these are slum areas where you can see open low rise, open low rise are the government housing areas, large low rise are 8 are the industrial areas, etc. So, these are the prominent one which we saw in Bhopal. This is Bhopal planning area. This was in 1990 when the development has just started around Bhopal, and we saw the urban core areas or the city areas, now it is called old city, where this was compact low rise development. Now, with over the 20-30 years, if we see 2020, we have seen this is the kind of development we are having, where mostly it is compact low rise. Then now this is again we are seeing large low rise, open rise which are spread, and this is sparsely built areas, that is on the fringe areas, and we will see compact low rise and open low rise, large low rise areas also here in between. So, this is what is the typology now and classification. And if we see into the surface temperature, we can actually relate where the temperatures are high and low looking at the LCZ. So, this is the research paper with Rakesh, and it is there on site, and we can see whether what kind of LCZ has what kind of land surface temperatures. Okay. And this is the LCZ classification which is prominent in Bhopal, and we can see the area under LCZ D is 38 is water, I guess, agriculture area, and this is agriculture area which is around Bhopal in the whole planning area, because we are taking, and then rest is LCZ, you can see 6 as 2.8, 9, all these are the areas which are prominent in Bhopal. Now, what we will do in our exercise is, we will try to find out those locations where before this, can you put up the another presentation? दूसरा presentation लगा दीजिए. Yes. Okay. So, keeping in mind what kind of geometry we have to see. So, whether there is variation in building density, height, size, which is again we reflected into land our local climate zone classification. Then what kind of activities, whether it is residential or industrial, that we have to see. Then what kind of building and material it is. So, that again is again a parameter that we have to look into. Then water and vegetation. So, all these things are actually we are trying to capture in our LCZ also. So, these are being considered in our LCZ, and if I have showed you in my presentation, yeah, this is what like there are different processes, different surfaces, and together they form a urban ecosystem or LCZ that we are seeing. So, because there is a particular sun power, there is a wind flow, and all together they will categorize what kind of microclimate we have in an area. And using this only we had I have in my study categorized into forms. So, whether what kind of vegetation is here, what kind of built is there, water is there or not, and this is how we can categorize the forms in our areas. So, same way if we go into our areas, what we will do is we will go to our selected sites and we will do such kind of sensor based studies in different areas. We will take the recordings, air temperature, relative humidity, wind speed and globe temperature, and we will try to capture. I will ask you all to just note down what is these parameters in a particular location. So, we will ask you to write location 1, location 2, we will just go to for 4 locations, and each location you have to note down these parameters, and then we will come back and see what are those, whether there are differences in these TA, RH, wind speed and globe temperature. So, that we will aim for. So, but as you must have seen in the yesterday's tutorial, we need lot of data for our creating our evidence, and we are just going to tell you how the observations are taking. So, one reading is never enough. We have to do it multiple times and then we have to do statistically proof that whether there is a relationship between the comfort or not. So, these are the parameters, and what we are aiming is, or these are our independent parameters, and our dependent parameter is whether we can take it land surface temperature, any thermal profile component. So, it could be land surface temperature, what is the temperature, or we can take human heat stress, human comfort indices like heat stress, humidex, there are many indexes, and we will try to relate it with that, and we can assume that at 30 degrees or 30 degrees as a human we feel normal during a particular season, and if it is going more than that or less than that, then there is a variation in the comfort level. So, that way we will check what is the situation, whether how much it is deviating from the mean areas. Okay. So, now we will go and just see how we are getting. Okay. So, going back, let's just close this and then put the previous slide, previous presentation. पहला वाला yes, yeah, this is good. Okay, so this is Manet, our campus. We are here, this courtyard, and what we will do is we will start taking reading. These are the civil department, mechanical, and the 4 building areas. So, they mostly these are paved. So, we will try to take one reading here, because this has a particular type of urban form which is devoid of major vegetation, it is all paved, it has a particular height. So, we will take one reading here, then we will go to nearby this lake, this is a small water body. So, we will go and take the observations here, then we will go to these faculty house, faculty accommodations. So, we will go and take here, this here,
behind top in town.
I think here, yeah, this area. And if we have time, if time permits, this is a very typical form of slum areas which is very close within this area. So, these are the slum areas you can see. So, we can go here and take readings, and these are slum rehabilitation authority area. So, these are G+4. So, there is very good contrast. These are very, here the aspect ratio is very less. They have lot of shading here. They have rises, but these are compact but open and low rise. So, this is very different type of LCZ that we can see. So, we can go here, here. So, bus can go till here, we will have to walk this place and take the readings. And this area is again row houses, row housing, which we said was LCZ 3. It is compact mid-rise housing. So, but it has lot of vegetation, and again, so we will see how much time we had. We will try to take 4 points, 1, 2, 3 and 4 here. Okay. So, clear, any doubts? No? We will go and take recordings or take the observations and then come back and analyze it. Okay. Recording लेंगे वहाँ पे. So, before that we will just go and see the equipments, right.